Today we're going to do an example involving quadratic splines, and we're going to work with that coronavirus data that we've been working with, which only has 11 weeks worth of data, so n equals 11 for us, which means we'll create 10 splines. And the spacing is by one. You know, it starts off with week 0, week 1, week 2, week 3. So all these HIs are just 1. That's going to make this equation up here pretty simple. Let's go ahead and start writing some of these in. So we'd have B1 times 1 plus C1 times 1 squared is equal to F2 minus F1. Just plugged in I equals 1. And then the next thing to note is C1 is actually equal to 0, so this equation is just B1 is equal to F2 minus F1. And then the next equation for I equals 2, we'd have B2 times 1 plus C2 times 1 squared is equal to F3 minus F2. And I'm actually going to move that over a little bit. There we go. Because there's something I'm going to want to point out here eventually. And let me write one more before we go to the end. We want to go all the way, actually, not to I equals n. That was a typo there. That should be n minus 1. This is what it is in our derivation from yesterday. And if we go to n minus 1, what's that last equation look like? Well, n minus 1 for us is 10, so that would be b sub 10 plus c sub 10 is equal to f sub 11 minus f sub 10. All right, and so that is 10 equations. I'm going to actually just write that at the bottom. 10 equations. And let's start the next set of equations. Okay. All right, so we'll plug in 1. So we'll have B1 minus B2 plus a 2C1. Remember, C1 is 0. So it's just B1 minus B2 is equal to 0. And then our next one will be B2 minus B3 plus 2C2. And remember, H2 and H3 and H4 and H5, all those are going to be 1. This is our next equation. And if we were to go to our last one here, we'd be plugging in n minus 2, so that's going to be 9 for us. 9. B sub 9. Okay, so this gives us a large system of equations, and let me point out how many equations we have here. We have 9 equations. So we have a total of 19 equations. Let's think about how many unknowns we have. We have unknowns B1 through B10. We know what C1 is, so we only have C2 through C10. So this is a total of 19 unknowns. Now, let's think about how we're going to stack our unknowns. Because our unknowns are going to be in a vector, Let's think about what that might look like. Well, we had just said all of our unknowns. Let's start writing them in here. We'd have b1, b2, all the way up to b sub 10. And then it would start at c2, and it would go all the way down to c sub 10. All right, and so if we want to be able to easily code this, we don't want to have these separated into B's and C's like this. For simplicity, let's just keep counting here, and I'll show you what I mean. So this would be, you know, the first element, the second element. Okay. So when we get to this one here, this is, we could technically call B11. We could call this one B12. And this last one, okay, let's just point out what the formula is. If you look at the subscript on the C, if you add 9 to it, you'll get the subscript on the B. So 3 plus 9 is 12, 2 plus 9 is 11, and 10 plus 9 would be 19. Okay. But notice that number. That matches our total number of equations, which is good. Okay. Let's make these same changes in our equations over here. So you can see that this first equation started with C2, so we're going to call that B11. Call this B12. And right, we're just adding 9 to that index, so this last one would be B19. And then if we come over here, this is B11, B12, and lastly, if we're stopping at C9, not C10, this is B sub 18. Let's work our way into MATLAB and at least get the data imported, and then we'll start trying to get our system of equations. Okay. So here we are. And so again, I'm going to just import that coronavirus data. You might already have it in here, but I'm going to need to go to import data. And I have this on my desktop. And coronavirus cases is what it's called. And here in a second, there we go. This should pop up. I only want to highlight the data. Okay, the week number and the total number of cases. And then I'm going to import. Okay, we were told it was imported, so I'm going to click this X. And we want to convert this from a table to an array. Okay. And this was called, again, coronavirus cases. Okay. And let's pull all this, let's call this thing, oops, I wanted to call this thing here data. That looks better. And I want to break it into two pieces. I'm going to take our X data, which should be the first column, okay, or T, whatever you want to use here. In either case, it's our independent variable. But it is in the first column, and in the formulas that we just set up, we were calling the y values f's. So I'm going to say f equals data, and we'll take the second column. Okay. And let's just give this a plot, okay? Because like usual, we're going to want to check our work when we're done. So let's just get x comma f. And let's just make sure that this is running right now without any issues. I'm going to go to editor and hit run. Okay, looks great. And so our goal here is to connect every single one of these points with a quadratic. And hopefully it'll give us kind of a smooth looking curve through this data. All right. Now, there was one easy part to this. You might not remember this from the video yesterday, but the A values, right? The A values should just be equal to the F values. So we're done there for the A's. It's the B's and the C's that we have left to find. All right, let's move on to the next part. The easiest part to probably do next is, I want to just point out real quick, we will have some system, like A times some vector is equal to some other vector. Okay. This A matrix here is going to be filled with the coefficients for B1 through B10 and C2 through C10. The X's here would technically be our B's and our C's, the ones I just listed. And then over here is the other side of the equal sign, okay, this B here. So this is what I'm going to have us set up right now, okay, is this vector B over here. I'm going to maybe call it the right-hand side vector. And let's maybe even call it V. Yeah, let's call it V. So I'm going to just set up its size first. Remember, we had 19 unknowns. So I'm just going to fill this thing with zeros, okay, for now. Okay, 19 by 1. Okay. But we're going to want to fill in some of these other spots. But you'll see why it was kind of convenient for us to write or fill the whole thing with zeros to begin with here in a second. Okay. But we will need a for loop. Let's go back to OneNote real quick. All right, so let's do these 9 equations here first, and then we'll do this set of 10 next. Okay, but these are all going to be in the same matrix. It just means that this will consist of the first 9 rows, and these 10 equations will consist of the next 10 rows. Okay. All right. Now, if you look at the right-hand side of these 9 equations, it's all 0. Okay. So equations 1 through 9, the right-hand side is 0. Well, we've already taken care of that. But we do need to fix the right-hand side. You can see on the right-hand side for equations, let's see how many equations this would be. This would be equation 10, right? The first one would be the 10th. And how many are there? Okay. Well, there's 10 of these. Actually, let's count this a little bit differently. I want to make sure we're not off by 1. This is the 10th, 11th, 12th. Okay. So notice that the second digit of what I was saying was 1 behind here. Okay. So if we were 1 behind here, that would be 19. So equations 10 through 19. Right, let's create a for loop that can handle that. Okay. So 10 to 19. I equals 10 to 19. And we'll just say V of I is equal to, and this should be equal to, right, 2 of these F's subtracted. But the one thing to keep in mind here is our index is going to be a little bit different. We're saying, right, this is line 10, 11, 12, all the way to 19. But which F's do we want here? If we look back here, notice we want to start off with 2 minus 1 and end with 11 minus 2. So we're going to need to adjust what we have a little bit. Okay. Let's see here. So again, we wanted to start with 2 there. Okay. So how about maybe I minus something, or something minus I? Let's see. Let's try I minus 8 here. And I minus 7. Or actually, let's make that 9. So let's see if this works. If you plug in I equals 10, you'll have f of 2 here, and f of 1 here, which is what we wanted for the first one. And for the last one, we want it to be f11 minus f10. Let's see if that's the case. Okay. So if I were to plug in 19, I would get 11, and here I would get 10. So that does work perfectly. Okay. So I'm going to go ahead and end that loop. And now on to the hard part. We're going to want to start setting up a matrix that contains, again, these 19 equations. Let's put a comment in our code here. Let's say first 9 equations. And also, while we're at it, let's just create a blank matrix here. Let's maybe call it M. Okay. We'll start off with a blank one. M equals, and it should be a 19 by 19, right? We have 19 unknowns. Okay. So if we were going to do that, we could say zeros of 19, comma, 19. Okay. But yeah, let's start setting up those first 9 equations. So how about for I equals 1 to 9. Okay? Equations 1 to 9. Okay. And let's start off by thinking about, okay, again, we're looking at these red equations for the first 9. Okay. Let's just think about the first element in all these equations, b1, b2, b3, b9. So that's b1 on equation 1, b2 on equation 2, b3 on equation 3. So that means the diagonal is just going to be 1, right? The coefficient in front of all these b's is just 1. So I'm going to go in here, and I'm going to just say m of I comma I is equal to 1. And let's see what we have next here. The next element in each one of these is minus b2, minus b3, minus b4. So this is just one element to the right of b1, one element to the right of b2. Okay. So if we were to look at this, okay, we're still in the same equation, but we're one more column over. Okay. But notice all those coefficients are minus 1. Okay. So when we're on equation I, and we're looking at the I plus 1th column, the coefficient should be minus 1. And then the last thing we have in these equations is the plus 2c2, 2c3, 2c9. But I do want us to be a little bit careful here. These c's, remember, we're going to call them b's. We're going to have them indexed 11, 12 through all the way up to 18. But the thing to be careful about here is that 2c2 is not part of the first equation. So in our little loop here, I'm going to say if I is greater than 1, then we'll perform this next thing. Okay. Maybe I'll actually write in an m here. And I'm going to put in 2 n's, one for the if statement and one for the for loop. Well, let's go back and see if we can get the indexing right. But I will say, we know that we're going to be on equation I. The question is what column are we going to be in? Okay. So let's go over here. So notice this is 2 and this is 11. So we added 9 to get the index. 3 plus 9 to get the 12. Okay. So we're 9 over, aren't we? 9 over from whatever that first index is. So if we're on index I, then we want to be on index I plus 9. Okay. Let's go put that in there. I plus 9. And what should it be equal to? Well, the coefficient in front of all those c's is 2. So let's go ahead and make that a 2. Now let's create the next 10 equations. Okay. So equations 10 through 19. Okay. Switch back to OneNote. So now we're focused in on these purple ones. Okay. Let's start off by taking care of the b's in each one of these equations. Okay. It starts with b1, ends with b10. Okay. 10 equations. Okay. So I'm going to go back in here. We'll start a for loop. So for I equals, okay. And again we're going to go equation 10 to 19. And then next here, we want to, again, be in equation I. Okay. And the question is what column do we want to be in? Okay. So let's go back and look. Well, B1 would be column 1. B2 would be column 2. B3 would be column 3. Okay. So we want to count from 1 to 10. For our column here. So what we're going to need to do is we're going to want to do I minus 9. Let's make sure that that works there. Okay. So if we were to start off with 10, that would give us column 1. And if we were to go all the way up to 19, okay, that would end us at column 10, which is what we want. All right, well, we want all these to just be equal to 1. If you go back and look at the coefficients for B1 through B10 in these 10 equations, it's 1. Okay. So 1. Okay. Let's move on to the next part. I think we have, what do we have? We have C's here now. Okay. So B11, B12, all the way to B19. But notice we have the same thing going on in that for the first equation, we don't have a C to deal with. So we'll want to skip it. Okay. Let's make sure we do that. I'm going to replace this with an if. Okay. So if I is greater than 10, we'll do this next step. We'll still be on equation I. The question is again, what column? Let's look at what the coefficients are. That part's easy. The thing in front of all the C's happens to also be a 1. So I'm going to say equal to 1. And now let's think about the column. Okay. So we start off with B11, and then B12 to B19. Okay. So we want to make sure we're starting with B11. Okay. B11. Now notice if you were to let I be 10, right, it's not going to do this next part. But once you have I equals 11, that's what we want to be on, is the 11th column. So this is just going to be M of I comma I. And we want to end with, right, I being 19 here. Right, B19 was the last one. Or sorry, it says, yeah, B19 for C10 there. There we go. All right, so that takes care of that. We need to end the if statement, end the for loop. Okay. And so we've taken care of everything. We've created that M. Okay. Let's point out what we're about to solve here. Solve. And we have M as the matrix. We have our coefficients, which maybe I'll call those C. Actually, I'm going to call them coefs. Okay. So we have m times the vector of coefficients is equal to that vector v we created. To solve this system, you would want to do m backslash v and this would give us the coefficients we need. Let's go ahead and assign, you know, which one of these coefficients are a's, which ones are b's. So let's maybe start off with the b's here. So b should be equal to coefs, and this should be what elements 1 to 10. C should be equal to the coefficients, and actually I'm going to fill something in here. We actually know what C of 1 is, don't we? We know C of 1 is 0. But the rest of these C's from 2 to 10 are equal to the coefficients from 11 to 19. Okay. So we now have our A's, B's, and C's. And if we wanted to display those, we could. Let's go ahead and run it, make sure we don't have any errors before we go any further. Looks like I have some things unsuppressed possibly that I don't want. Let me just double check here. Yeah. Several things. Okay. Let's try and run that one more time. Okay. So let's see our coefficients. We should have, yeah, there's our A vector, and here's our C vector. And I don't like that one of these is a row and one of these is a column vector. Let's see if we can fix that here. So maybe, which one of these came out to be a, oh, it was C. So I'm going to say comma 1, and that should make that into a column vector. I just want to be consistent here. Ooh, that's not right. I think we're having an issue of the fact that I don't have the clear all at the top here. And I think it's mistaking the size of C here. So I think I'm going to try something else here. I'm going to try C equals zeros from, let's see here. Let's make this a, what, 19, or not 19 by 1. There's 10 of these. So how about a 10 by 1? And then we'll fill in 2 through 10 with the values from coefs. Let's give that a run. And I'm going to unsuppress, or leave A and C unsuppressed down here. I think that's going to fix our problem. Yes, it did. Okay. So next we'd like to actually check our work here, see if this actually works. So we're going to want to essentially create 10 functions, right? We were going to have 10 splines. Let me make a little bit of space here. So how about for I equals 1 to 10? We'll use, we used y at all here today? No, we haven't. Actually, let's use maybe big F and big X. Okay. Let's say big F. And this will be the ith function. The variable will be big X. Okay. And the question is what is the function going to look like? Well, it was supposed to be A. Okay. So the ith a is what we're going to start with, plus the ith b, okay, times x minus the ith x, okay, plus, and I need an asterisk here, plus the ith c times x minus the ith x, and then squared. And I'm going to make sure that this can handle vector inputs, so I'm going to put a dot here. I'm going to make sure that my variable is a capital X rather than lowercase x. There we go. And so that should create our 10 splines. And we want to plot all these things. Okay. So we want to plot f sub I. And the question is over what interval? Well, right, we started with with week 0 and went up to week 10. So we'd be going from 0 to 1 first. So that'd be I minus 1. Okay, and going to I equals 1. There we go. Right, and so then the next interval would be if you plugged in I equals 2. Okay, I equals 2, then it would go 1 to 2. And if you did I equals 3, you'd go 2 to 3, and so on. Okay. And we want to hold on. Okay. And then we can end that loop there. Okay. And let's see, is there anything we would like to suppress? I'd like to suppress that. And I'd like to make this f plot. Okay. F plot for when we just input the function there in the domain. Let's go ahead and run it. Okay. And you know what? I want to be able to see the asterisks here, but you can see we have this nice smooth curve here now. Okay. So I needed a hold on here. There we go. Okay. There is our quadratic splines.